China's Air Force says they may have figured out how to land a hypersonic drone.
China has been shaking up things in the world of aviation recently. All this tension is as a result of their hypersonic aircraft that supersede everything we ever saw in the world of aviation. This jet will allow people to reach any destination on Earth in less than 2 hours.
So what we're talking about here is called point-to-point space travel. The idea is you get in a rocket with a couple hundred other people and you blast off above the atmosphere and you spend about an hour traveling above the Earth.
While the concept of a hypersonic jet for tourists seems like something out of science fiction, it has been confirmed that this project is real. What exactly is China up to?
What is hypersonic technology and why are the Chinese better at it than we are?
Hypersonics is going really fast, so probably about 4,000 miles an hour.
What are these massive features that can't be ignored? Join us in this video as we share every fascinating detail about this hypersonic jet. The future of aerospace. China's hypersonic jet changes the game. Since China's announcement of their hypersonic jet, Nanchang No. 1 and its crazy features, other nations have been thriving hard and looking for possible ways to match up with this new technology. This is not something China just came up with overnight. It's something that took careful planning, analyzing, studying, and testing. They did all these because they wanted to achieve the best, and from the look of things, they are on to it. Before this, other nations had been focusing on supersonic aircraft, but now the competition has been intensified again. It is not the speed of Nanchang No. 1 that makes it top-notch. Every detail about this aircraft is massive. And trust China when it comes to creativity, technology, and innovation, they always have it right. What exactly are these details? And how are other nations leveling up to this? Keep watching to find out. Let's start with its speed. The Nanchang No. 1's design is its extraordinary speed. The aircraft will cruise at Mach 6, which means it will be traveling 6 times faster than the speed of sound. That's huge. To put that into perspective, Mach 1 is the speed of sound, which is roughly 767 miles per hour, that is 1,234 kilometers per hour. Mach 6 is a staggering 4,600 miles per hour, which is 7,400 kilometers per hour. At such speeds, a journey that would normally take many hours could be completed in a fraction of the time. For example, a flight from New York to London, which currently takes around 7 hours, will be completed in less than an hour. The key to achieving this incredible speed lies in the aircraft's cutting-edge engine system, known as the Mutter engine. Mutter stands for Multi-Ducted Twin-Turbine Ejector Ramjet, and it combines several different types of propulsion systems to allow the Nanchang No. 1 to operate at both lower and extremely high speeds. The engine design is intended to ensure smooth transitions between these different modes of propulsion, helping the jet maintain stability and efficiency throughout the flight.
Very high-speed jet propulsion with no moving parts, and they're called ramjets. They've been around for a long time, but to make a practical ramjet, which is lightweight, durable, and powerful.
The development of this technology has been years in the making, with extensive computer modeling and small-scale prototypes providing crucial data. It is also designed to use turbofan engines for takeoff and low-speed flight, rocket engines to boost the jet to supersonic speeds, and ramjet engines to maintain hypersonic speeds. In heat management, there is this challenge of propulsion. Hypersonic jets require engines that can function at both subsonic speeds that are below the speed of sound and hypersonic speeds. The Nanchang No. 1 jet relies on a combination of turbofan, rocket, and ramjet engines to achieve its incredible speed of Mach 6. Each engine type plays a role in different stages of flight. Turbofan engines are efficient for lower speeds and can operate during takeoff and landing. As the aircraft accelerates, the ramjet and scramjet engines, which are air-breathing engines that use the high-speed air intake to compress the air needed for combustion, will take over, allowing the jet to push beyond Mach 5. Ramjets are a type of air-breathing engine that becomes more efficient the faster the aircraft moves.
Ramjets only work when you're going really fast, like Mach 3.
But they are unable to operate at lower speeds, which is why the jet also relies on the other engines during takeoff and landing. The rocket engine helps to bridge the gap between supersonic and hypersonic speeds, allowing the Nanchang No. 1 to accelerate smoothly through different stages of flight. This multi-stage propulsion system is one of the most advanced ever developed and has been praised as a significant breakthrough in aviation technology. When the aircraft was initially tested, it was very promising. The smaller, unmanned prototype weighs only 500 kilograms and has already demonstrated the capability to reach high speeds in lab conditions. It will start operating fully in 2025 as the year is almost over. This jet will be in operation for decades, transporting passengers around the globe at unprecedented speeds. According to reports from China, the aircraft will be able to carry up to 10 passengers, making it ideal for high-speed business or leisure travel. The development of the Nanchang No. 1 has been led by Yin Zheyong, a leading scientist in the project. Yin and his team began working on the concept in 2019, and despite the challenges they have faced, they remain optimistic about the jet's potential. Yin has described the project as a breakthrough in both technology and travel, emphasizing that hypersonic flight could change the way people think about global transportation. Lin is a director of science and technology with the Aero Engine Corporation of China, and has even gone so far as to suggest that this new form of travel will change human civilization. The Nanchang No. 1 is widely seen as a direct rival to Concorde, the legendary supersonic jet that was introduced over 50 years ago and retired in 2003. The Concorde had a maximum cruising speed of Mach 2.04, or we should say 2,179 kilometers per hour, making it twice as fast as the speed of sound. Although impressive for its time, the Concorde's speed is far surpassed by the Nanchang No. 1, which is designed to fly at 3 times that rate. The Concorde's retirement in 2003 left a gap in the market for high-speed air travel, but advances in technology are bringing the dream of supersonic and hypersonic travel back to life. Several companies and countries are working on projects that could revolutionize the aviation industry, with speeds ranging from Mach 1 to Mach 6 and beyond. But the Nanchang No. 1, as the name implies, really stands out in all of these. The project is one of the most promising efforts to push the boundaries. It will not only change the way people travel, but also open up new possibilities for scientific research, military applications, and space exploration. The ability to travel at hypersonic speeds would allow for faster global travel, quicker transportation of goods, and new opportunities for international collaboration. The Nanchang No. 1 is a great leap forward in aviation technology. Its success is paving the way for the development of even faster and more efficient aircraft in the future. As the world becomes more interconnected, the demand for faster travel options will only increase, and hypersonic jets like the Nanchang No. 1 is the answer. The development of the Nanchang No. 1 is an exciting and groundbreaking advancement in the world of aviation. But China is not the only one trying to introduce something new. Other countries are building their own jets and aircraft. The whole features and plans are all thrilling. Stay tuned so we can see what these guys are up to. Other countries attempt to beat up Nanchang No. 1. The race to develop hypersonic aircraft has caught the attention of many nations and private companies across the globe, all of whom understand the potential of this technology, and they are all trying to build up the best. Companies like Hermeus, Stratolaunch, and Hypersonics are leading the charge in the United States and Australia, with each taking different approaches to overcome the unique challenges of hypersonic flight. Other countries like Russia are also heavily investing in similar technology, with the aim to build the fastest aircraft the world has ever seen. The international competition to achieve reliable hypersonic travel or military applications is serious, and this next frontier of aerospace engineering has sparked a global technological race. Hypersonic aircraft, which travel at speeds exceeding Mach 5, as said earlier, which is 5 times the speed of sound, present incredible possibilities for both commercial and military applications. In the commercial sector, this technology could revolutionize air travel, making it possible to fly from one side of the globe to the other in just a couple of hours. The time-saving implications for business, tourism, and international travel is what makes it more intriguing. Long-haul flights, which currently take up to 12 hours or more, could be reduced to a matter of minutes. These advancements could make the world feel much smaller, improving global connectivity in ways we never thought possible. In the military and defense sector, hypersonic aircraft are seen as game changers. They serve as delivery systems for weapons or provide new capabilities in surveillance and reconnaissance. The extreme speeds make it difficult for enemies to detect and respond, which is a significant strategic advantage. Some experts believe that hypersonic missiles, for instance, could outpace missile defense systems, giving countries that develop this technology an upper hand in modern warfare. The technology behind hypersonic flight is complex, and developing aircraft capable of sustained hypersonic travel involves overcoming significant engineering challenges. So these guys are putting in a lot of work to make sure everything comes out well. The speed of these jets generates immense heat due to the friction of air molecules against the aircraft's surface. Managing this heat and preventing structural damage to the aircraft are two of the biggest problems engineers face. For example, temperatures can soar to over 1,500 degrees Celsius, which is 2,732 degrees in Fahrenheit, at Mach 5 and beyond. Traditional materials used in aircraft construction can't withstand such heat without compromising the safety and integrity of the jet. This is why companies like Hypersonics are researching new materials, such as ceramic matrix composites, which are lightweight, heat-resistant, and capable of handling extreme temperatures. These advanced materials are important for the success of hypersonic travel, as they help reduce heat and protect vital components of the aircraft. One of the key players in this global race is Russia, which has been making significant strides in developing hypersonic weapons, vehicles, and jets. Russia's Avangard hypersonic glide vehicle is designed to travel at speeds exceeding Mach 20, making it nearly impossible for missile defense systems to intercept. Russia has also developed the Kinzhal hypersonic missile, which can be launched from fighter jets and reach Mach 10. These advancements have sparked concerns among military analysts, as hypersonic weapons could definitely change the landscape of modern warfare. Meanwhile, the United States is also heavily investing in hypersonic technology. In addition to the efforts by private companies like Hermeus and Stratolaunch, the United States government, through organizations like the Defense Advanced Research Projects Agency and NASA, is funding research into hypersonic propulsion and materials. Defense Advanced Research Projects Agency's hypersonic air-breathing weapon concept is a notable project aimed at developing hypersonic cruise missiles for military use. NASA, on the other hand, is interested in the civilian applications of hypersonic technology and is working on the X-59 quiet supersonic transport.
Now, NASA and Lockheed Martin have unveiled what they call the next generation of supersonic aircraft. The makers say the experimental plane combines supersonic travel with low noise. The public got the first glimpse of the new X-59 research plane at Lockheed Martin's Design Center in California.
A supersonic aircraft that could pave the way for future hypersonic planes by reducing the sonic boom, one of the key barriers to civilian supersonic and hypersonic flight. Beyond military and civilian aircraft, there is also potential for hypersonic technology to play a role in space exploration. Reusable hypersonic vehicles will be used to launch satellites or other payloads into space more efficiently than current rocket technology allows. For instance, Hypersonics' plan to develop the Delta Velos orbiter, a hypersonic vehicle for launching small satellites, is a significant step forward in space launch technology. This will make space access more affordable and frequent, enabling a new era of space exploration and commercial space activities. The hypersonic race is not just limited to a handful of countries. Europe is also investing in this technology. With projects like the French VMAX in full, we call it Vehicle Maneuvering Experimental, which is aimed at developing hypersonic weapons and aircraft. India has also shown interest in hypersonic technology, working on the Hypersonic Technology Demonstrator Vehicle, a program with the goal to create a hypersonic missile for its military.
Major milestone in the Make in India story. Indian scientists have successfully tested hypersonic technology.
Despite the progress being made, there are still many challenges to overcome before hypersonic jets and aircraft become a common feature of our skies. Hypersonic flight promises to revolutionize aviation, but the road to achieving it comes with technical and economic challenges. That's what has been holding this whole thing.
Well, imagine this, flying from Tampa to China, Australia, or anywhere else in less than an hour. Flight engineers at the University of Central Florida are figuring out the secret to safe hypersonic travel.
While the idea of flying from New York to Tokyo in under 2 hours is quite exciting, this technological breakthrough comes with its own set of difficulties. These challenges range from its costs and regulatory obstacles to fundamental issues in physics and the material. Let's address the elephants in the room that we can't ignore. You really should know what has been holding this whole massive project in all nations, so we don't just blame them for not pushing this innovation too fast, the way we might all want it. Disturbing challenge countries faces in tackling all this innovation. The most immediate obstacle to hypersonic travel is its cost. Developing even a prototype of a hypersonic aircraft is extremely expensive. Creating a jet capable of sustained speeds above Mach 5 requires advanced materials, sophisticated engines, and innovative cooling systems, all of which come at a premium. The amount of research and development needed to bring such an aircraft to market caused billions of dollars. That is way too much. Then there's mass production. Building just one hypersonic prototype could be tens of millions of dollars, but mass producing these aircraft for commercial use would require a global-scale industrial effort. This would involve specialized factories, high-end manufacturing processes, and an unprecedented supply of advanced materials. Costs will all trickle down to ticket prices, making hypersonic flights prohibitively expensive for all but the wealthiest travelers. While companies like Hermes have set goals to lower these costs through reusability, we are still a long way from making hypersonic travel affordable. Let's not forget operational expenses. Hypersonic jets will consume immense amounts of fuel. Moreover, regular maintenance would be significantly more expensive than that of current commercial jets. For example, managing heat damage caused by the friction of air at Mach 5 or beyond will require more frequent inspections and costly repairs. Even if an airline could afford to buy these jets, the ticket prices will likely be too much. Some estimates suggest that a single flight on a hypersonic passenger jet will cost upwards of $100,000 per seat. That is totally crazy. Why spend so much of that money on traveling? No matter how wealthy one may claim to be, there are certain things that are just too much. Not that you can't remove such an amount of money. But is it really worth it? Well, there are people who will still go for it. Another major difficulty is the noise produced by a hypersonic jet. Supersonic flight, such as the Concorde, was banned in several countries due to the notorious sonic boom. This loud noise occurs when an aircraft breaks the sound barrier, and it can disturb people on the ground, shatter windows, and potentially harm wildlife. The Concorde, which operated in the 20th century, faced bans in many countries because of this issue, restricting it to routes over oceans. The same, if not more stringent, restrictions would likely apply to hypersonic jets. A hypersonic aircraft would create an even louder and more destructive sonic boom. This issue has led some companies like NASA with its X-59 quiet supersonic transport to focus on reducing or mitigating the boom's intensity. NASA's prototype is working on shaping the aircraft in such a way that the boom becomes a soft thump, that is a low boom, which is less disruptive to those on the ground. However, this technology is still in the experimental stage, and it is unclear if or how it could be adapted for hypersonic flight. Unless this issue is resolved, countries with strict regulations on noise pollution are unlikely to allow hypersonic aircraft to operate in their airspace, limiting potential routes and commercial viability. One of the greatest technical challenges in hypersonic flight is dealing with the immense heat generated by flying at such speeds. Hypersonic aircraft experience temperatures that can reach 2,500 degrees Celsius, which is much hotter than the melting point of common materials like steel and titanium. This heat is generated primarily due to the friction of air molecules slamming into the aircraft at high speeds. These extreme temperatures are a great risk of melting the aircraft's skin, degrading the structure, and putting the passenger's safety at risk. Is just mere traveling. You shouldn't be risking your life for it. Well, to manage this, engineers have been developing advanced materials and coatings for the thermal protection system. Traditionally, the thickness of a thermal protection system is not uniform, but instead decreases in the direction of the airflow. Materials like ceramic matrix composites are being used because they are lightweight and can withstand high temperatures. But managing the heat load at hypersonic speeds remains a huge challenge. The surfaces of hypersonic jets must be cooled, which is typically achieved through passive thermal radiation. Yet, this only works for limited durations, and cooling such a vehicle for long-duration flights remains one of the thorniest challenges. Even worse, predicting how and where heat will build up on the aircraft has been very difficult. The transition from laminar to turbulent airflow, a critical aerodynamic shift at high speeds, creates unpredictable changes in heat loads. This uncertainty increases the difficulty of designing an efficient thermal protection system. Another thing is that heat generated externally is not the only concern. Heat produced by internal electronics like flight controls and avionics exacerbates the issue. If these systems overheat, they will fail mid-flight, and that's definitely catastrophic consequences. Another practical limitation of hypersonic jets is seating capacity. Current designs, like the aircraft being developed by Xiamen University, propose accommodating as few as 10 passengers. The limitations are largely from the need to reduce weight, optimize aerodynamic efficiency, and allocate sufficient space for thermal protection systems and fuel. Simply put, larger planes will face even greater thermal, structural, and fuel challenges, making scaling up difficult. A plane that can only carry 10 passengers will not be economically feasible. Commercial airlines focus on volume. Larger planes can carry hundreds of passengers, allowing them to spread costs and maximize profits. A hypersonic jet with just a handful of seats would have to charge extraordinary amounts for tickets to cover operational costs. While some businesses might be willing to pay these prices for time-saving benefits, most of the general public would be priced out of the market. In an era when the world is dealing with climate change and increasingly turning to greener transportation options, hypersonic flight presents another challenge. We can't ignore this environmental impact. Flying at hypersonic speeds requires immense amounts of fuel, and the engines used, whether turbofans, ramjets, or scramjets, are not known for their fuel efficiency. Hypersonic jets will burn more fuel than conventional aircraft, resulting in higher carbon emissions per flight. This is particularly concerning given the global push to reduce aviation's carbon footprint. Talk more of the environmental damage, it is not even limited to carbon emissions. Hypersonic jets fly at much higher altitudes than typical commercial aircraft, often in the upper atmosphere. This raises concerns about the impact on the ozone layer, which is sensitive to emissions from high-altitude flights. Scientists are still studying the potential effects of hypersonic flight on the atmosphere, but there is already speculation that these jets will contribute to ozone depletion, worsening global warming. Without solutions to change their environmental impact, hypersonic jets may face strong resistance from environmental groups and regulatory bodies. The aviation industry is under pressure to become more sustainable, and introducing hypersonic jets that are environmentally damaging is a step backward. Bringing hypersonic jets into the commercial market would require navigating a maze of regulatory approvals. Aviation authorities such as the Federal Aviation Administration and the European Union Aviation Safety Agency would need to develop entirely new sets of rules and guidelines for certifying and operating hypersonic aircraft. Safety concerns are the main thing in these regulations, as hypersonic travel introduces risks that are not encountered in subsonic or supersonic flight. For instance, emergency procedures for conventional aircraft rely on the ability to glide or slow down rapidly if something goes wrong. At hypersonic speeds, everything changes entirely. Any malfunction would need to be addressed in a matter of seconds, and the options for safe recovery are much more limited. Developing safe protocols for hypersonic travel, from takeoff to landing, will require extensive research and testing, and it could take years before regulators feel confident enough to certify these jets for commercial use. While the road ahead is challenging, the progress made so far gives us hope that hypersonic travel might one day be as common as taking a traditional flight today. What are your thoughts on this innovation? Drop it in the comment section below. If you enjoyed watching this video, make sure to like, share, and subscribe to our channel for more. Also, click the next video shown on your screen. You will enjoy it.